Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, just like we promised in the previous video, we're going to focus on part 2 of Exponents and Surds for grade 11 mathematics, and that is how to solve exponential and surd equations. On that note, if you're new to this channel, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on any new videos we upload in the future. We have a lot to cover, so let's get right to it. Now, exponential equations and surd equations come in many different forms, and we're going to look at all those forms in this video. The first form is when you've got a power with the exponent as your variable that you need to solve. So you go, let's get right to it. That's a to the power of x minus, simplify the surd, that is 1 over cube root of 2, that's 2. Cube root of 8, that's 2, equals to 0. Therefore, 8 to the power of x is equal to, take everything that is not x to the right hand side like you would with any equation. Right now, express your 8 as a power. So you go 2 cubed all to the power of x equals to, express 1 over 2 also as a power, that becomes 2 to the negative 1, 2 to the power of negative 1. How? 1 over 2 is equals to 1 over 2 to the power of 1. Now, if you take this 1, 2 to the power of 1 to the top, it becomes 1 times 2 to the power of negative 1. That's how you find that thing. All right, therefore, when you're raising a power to another power, you must multiply the exponent, so that is 2 to the power of 3x equals to 2 to the power of negative 1. Now you've got two powers of the same base that are equal. Therefore, you equate the exponents. The exponents are equal. Therefore, 3x equals to negative 1, meaning that therefore x equals to negative 1 over 3. Now you would be done in other grades right now, but in this grade you're not done. You check. Very important to check, because you can get an answer only to find that it's not the right solution for that particular problem. So you need to check after every. Now, how do you check? You go the left hand side, you just substitute everything on the left hand side. Left hand side, wherever there is x, you substitute your answer here, which is negative 1 over 3. So you've got 8 to the power of negative 1 over 3 minus 1 over the cube root of 8, which is equals to, express your 8 as a power. Now that gives you, now that is raised to the power of negative 1 over 3 minus, simplify that, so that is 1 over 2, which is equals to, now the x's, the 3's cancel out. Okay, this 3 cancels out with this 3, and you're left with 2 to the power of negative 1, 2 to the power of negative 1, minus 1 over 2 can also be expressed as 2 to the power of negative 1, as you've seen in the last scenario. Now, a goat minus a goat, which is 2 to the power of negative 1, is equals to 0, which is equals to the left hand side. So we've proven that the left hand side is equals to the right hand side, which is equals to the right hand side, meaning that therefore x is equals to negative 1 over 3 is the solution. Is the solution. And that's how you solve that first equation there. Next question. We have a similar scenario. The only difference is that now the variable is a base, no longer an exponent. So first step is we change this format into an exponential format. So that becomes x to the power of 4 over 3. 4 over 3 equals to 405. Therefore, divide both sides by 5 and you're left with x to the power of 4 over 3 in the left hand side, which is equals to 405 over 5. Take out a calculator, that will give you 81. Now, therefore, you've got x to the power of 4 over 3. Let me fix that. X to the power of 4 over 3. And that is equals to 81. Now, express 81 as a power that is 2 to 3 to the power of 4. And now, to solve this, you raise this to the power of the reciprocal. The reciprocal of 4 over 3 is simply the number flipped upside down, and that is 3 over 4. Always raise to the reciprocal, because then the numbers cancel out and you are left with your x to the power of 1. Same thing you do to the right hand side. What you do to the left hand side must be done to the right hand side. That is the law of equations. Now on the left hand side, the 3's cancel. The 3 cancels with this 3, and the 4 cancels with this 4. They all cancel and you're left with x to the power of 1, which is x. Now that is equal to, on the right hand side, the 4's cancel and you're left with 3 to the power of 3, which is equals to 27. Therefore, x equals to 27. Now check. Very important to check every step of the way. Check. Check for x equals to 27. Left hand side equals to, wherever there is an x, you put 27. So that's 5 cube root of, where there is an x, we put 27. So that is 27 to the power of 4. That is equals to 5 in brackets. Okay, the square root of, the cube root of, that is the cube root of 27 to the power of 4. That gives you 531,441. That is equals to 5 times the square root of that number. The cube root, you go 3, second function, x to the power of y in your calculator, and then you punch in the number 531,441, and that will give you 81. 5 times 81, that is equals to 405, which is equals to the right hand side, meaning that therefore x equals to 27 is the solution. The solution still check out at this stage, so we haven't encountered any problems. Now the next one is very similar to a quadratic equation. In fact, it is a quadratic equation. Now the thing is, it's not so easy to see, but let me show you. The square root of z means z to the power of a half, right? Now if you square that, in other words, raise it to the power of 2, that becomes z. How? The 2's cancel out and you're left with z to the power of 1. Meaning that this z is simply the square of the square root of z. That's what that all means. Now, this type of questions, we use what we call the k method for it. So you go let k equals to the square root, which is square root of z in this case, or you can write it as z to the power of a half. Therefore, k squared is equals to z. K squared is equals to z, because that is z to the power of half squared. All right. Now you express the original equation with k instead of z. So that becomes 2k squared minus 7k plus 3 equals to 0. Now that is easier to factorize. If you still struggle with factorization, please consult the video I made on grade 10 factorization. So that is 2k and k, and then we've got 3 and 1. We've got negatives on both. All right, therefore 2k minus 1 equals to 0, or k equals to 3. Therefore 2k equals to 1. I know a lot of people skip these steps, but I don't recommend skipping them, because that's where a lot of silly mistakes are made. That therefore k equals to 1 over 2, or k equals to, oh, the k equals to 3. We're done with that. K equals to 3. Now remember, we're not solving for k, we're solving for z, or z to the power of a half in this case. So we go back to that. Now therefore z to the power of a half is equal to 1 over 2. This is one scenario. Now if you raise that to the power of 2 to get rid of the half, that's why. To get rid of the half, raise it to the power of 2. To get rid of a third, you would raise it to the power of 3. And to get rid of a quarter, you will raise it to the power of 4. And so on and so forth. So we'll raise it to the power of 2. Raise it to the power of 2. The 2's cancel here. And we're left with, therefore, z. It's equals to 1 over 2 all squared. That's 1 over 4. That's 1 squared over 2 squared. Or let's now deal with the other option. Z to the power of a half is equal to 3, meaning that we raise this z to the power of half to 2. Yes, you guessed that right. We raise it to 2 to get rid of the half. Therefore, z is equals to 3 squared, that's 9. So we've got two options. Z equals to a quarter and z equals to 9. Let's check if they both are admissible solutions. All right. Let's start with the z equals to 9. We can start with the z equals to a quarter. That's all right. Start with the z equals to 9. Oops, let me fix that. All right, the z equals to 9. We check. All right, check z equals to 9. All right, left hand side is equals to, that is 2z. Where there is z, we substitute 9. So that's 2, 9 minus 7 square root of 9 plus 3, which is equals to 18. That's what 2 times 9 is. minus 7 times square root of 9 is 3 plus 3. So that's 18 plus 3, that's 21. So that's 21 minus 7 times 3, that is also 21, meaning that therefore that is equals to 0, which is equals to the right hand side, meaning that therefore z to the power of half, z is equal to 9 is the solution. It's a solution. It's not the final solution though. We still have the other one to check. Let's check for z equals to a quarter. Left hand side equals to 2 in bracket 1 over 4 minus 7 the square root of 1 over 4 plus 3. That is equals to 2. So that is 2 over there, that is 1, so that you're left with 1 over 2, 1 half minus 7 and times the square root of 1 over 4, that's 1 over 2 plus 3, which is equals to a half minus 7 halves, 7 over 2 plus 3, which, okay, common denominator 2, 1 minus 7 plus 3, which is equals to negative 6 over 2 plus 3. Negative 6, that's negative 3 plus 3. Negative 3 plus 3. Let me fix that. Negative 3 plus 3. That is equals to 0, which is equals to the right hand side. The right hand side there. Meaning that therefore z equals to 1 over 4 is also a solution. Z equals to 1 over 4 is also a solution. Meaning that therefore z, not x, sure, so used to x. Therefore z equals to 9, or z equals to 1 over 4 is the solution. And that's how you end the answer to that question. Next one. This is another quadratic equation situation. Let me show you how. X to the power of a third, all squared or raised to the power of 2 is equals to x to the power of 2 over 3. So meaning that this is simply the square of that. We use the K method again. Let K equals to the square root x to the power of 1 over 3. Therefore, K squared equals to x to the power of 2 over 3. Now let's write the original equation using k's. So that's 2k squared plus 3k minus 2 equals to 0. Now this is an easier equation to factorize. Remember, if you need help with factorization, don't forget to consult my video on grade 10 factorization, because that is complete. So we've got one on the other one. So we've got plus 2 and minus 1. Therefore 2k minus 1 equals to 0, or k plus 2 equals to 0. Therefore, this is where a lot of silly mistakes are made. So that's why I don't skip the steps here. I'm very thorough here. Therefore, k equals to a half. Or k equals to negative 2. Now, don't forget, we're not solving for k, we're solving for x to the power of 1 over 3, right? Therefore, it means that x to the power of 1 over 3 is equal to, that's one scenario, 1 over 2. Now we'll raise that to the power of 3, yes, to get rid of the fraction. Yeah. We'll raise that to the power of 3 to get rid of the fraction in the exponent. Here they cancel out. Now you're left with x. Therefore x is equals to, now 1 over 2 cubed, that's 1 cubed, which is 1 over 2 cubed, which is 8. Or the second scenario, where x to the power of a third equals to negative 2. Now we'll raise that also to the power of 3 to get rid of the fractional exponent. So raise that to the power of 3. The 3's cancel out. Okay, now you've got, therefore, x equals to negative 2 cubed, that's negative 8. So you've got two solutions here that you need to check, 1 over 8 and negative 8. Now let's check them. Remember, always check. Never assume they are the correct answer. Always check. All right, let's check for x equals to negative 8. Left hand side. Remember, you just substitute. All right, let's substitute. So that's 2 in bracket. 2 in bracket. Negative 8. 4 to the power of 2 over 3. Plus 3 in bracket. Negative 8 to the power of 1 over 3. Minus 2. Which is equals to all right, now express your negative 8 as a power that becomes negative 2 all to the power of 3. So that becomes negative 8, negative 2 all to the power of 3. And that is raised to the power of 3. 1 over 3, I mean. That is raised to the power of 1 over 3. plus 3 with the same situation, negative 2 raised to the power of 3, again raised to the power of 1 over 3. Plus 3, you've got negative 2 raised to the power of 3, and all that raised to the power of 1 over 3. Now this is 2 over 3. That is raised to the power of 2 over 3. Sorry about that. That is raised to the power of 2 over 3. That is raised to the power of 1 over 3. Minus 2. Alright, all that mess. The 3's cancel here. So you're left with negative 2 all squared. So that's 2 with negative 2 all squared. Plus 3. The 3's cancel here. And you're left with negative 2 minus 2. That is equals to 2 times negative 2 squared, that is 4, minus 3 times 2, negative 2, that's minus 6, negative 6 minus 2. So that is 8 minus 8, which is equals to 0. Now that means x equals to negative 8 is a solution, so it checks out. Let's check the other one. X equals to negative 1 over 8, I mean. Let's check. Sorry about that. Let's check. X equals to 1 over 8. Now you substitute 1 over 8 everywhere. You've got x, so that's 2 in bracket 1 over 8 all to the power of 2 over 3 plus 3 1 over 8 to the power of 1 over 3 minus 2. And that is equals to, okay, 1 over 8 all to the power of 2 over 3 is equals to 2 to the power of negative 3 all to the power of 2 over 3, and the 3's cancel, and you're left with 2 to the power of negative 2. So that is 2 and 2 to the power of negative 2 plus 3. Same there, 1 over 8 is equal to 2 to the power of negative 3. So when you raise that to the power of a third, the 3's cancel and you're left with 2 to the power of negative 1. So that's 3 and 2 to the power of negative 1 minus 2. and that is equals to 2 to the power of 1 minus 2. Remember, when you multiply powers of the same base, you add the exponent, so that is negative 1 plus 3 over 2, because that's what that means, minus 2. So that is 1 over 2 plus 3 over 2 minus 2. Okay, that gives us common base, common denominator, 1 plus 3 minus 2, which is equals to 4 over 2 minus 2. 4 over 2, that's 2. So that is equals to 2 minus 2, which is 0. So this one also checks out. So your final answer is therefore, both of them are the solution. Therefore, x equals to negative 8 and x equals to, or x equals to 1 over 8 is the solution. Both of them give us a solution. Now here's another interesting one, where you've got your power that has an exponent that is x, but it's not quite the same as the other power. So what you do with this one is you immediately go, you decide which side do you want to keep your power with an x. Okay, let's choose the left hand side. So what we do is we're going to divide both sides by 3 to the power of x, meaning that we end up with 3 to the power of x on the left hand side and 64 over 27 on the right hand side. Now notice that this is a power of 3, that is a power of 4. So we change them into the powers. So that is equals to, all right, therefore 4 to the power of x over 3 to the power of x, that is 64 is 4 to the power of 3. How do I know it's gonna be a base of 4? This is what guides me. So you express 4 as a power with a base 4, 64. So that becomes 4 cubed over 27 is 3 cubed, so that makes life easy. But that means, okay, therefore, that means if you've got two exponents or powers with the same index exponent, then you can just go 4 over 3 all to the power of x. That's one of the laws of exponents. Same for the right hand side. Now notice that the bases are exactly the same now, 4 over 3 on both sides. When you've got powers of the same base equal, then you simply equate the exponents. Therefore, x is equals to 3. Now we check. Very important to check. Check. We're checking for x equals to 3 on the left hand side and the right hand side. Left hand side equals to 27 times 4 to the power of 3 right, 4 to the power of 3, and that is equals to 27 times 4 to the power of 3 is 64. 27 times 64, take out the calculator, that is equals to 1728. That's on the left hand side. Now let's check the right hand side. That is equals to 64 in bracket 3 to the power of 3. Okay, that is equals to 64 times 27, which will give us exactly the same answer, 1728. Now the left hand side is equal to the right hand side, meaning that our answer checks out. Therefore, x is equals to 3 is the solution. X equals to 3 is the solution. This is the solution. And that's how you solve that type of equation. Next, you've got what we call a scenario that needs to be squared on both sides. So whenever you get a situation where you've got a square root of another expression, binomial expression, or algebraic expression inside of it, you square both sides. So you go t minus 1. You square both sides to get rid of the square root sign. But because of the squaring, that means we'll be left with the need to check at the end, like we've done with everything, with all the questions now. That to the power of 2 equals to square root of 7 minus t, all to the power of 2. When you square a square root, it's like cubing a cube root. You get rid of the radical. Therefore, okay, now on the left hand side, we've got a binomial, t minus 1 all squared. T minus 1 all squared. I want us to deal with the right hand side first before we fix the binomial. So that's t minus 1 all squared equals to 7 minus t. Now t minus 1 all squared, when we're squaring a binomial, that's the first term squared. So that's t squared plus 2 times the product of the terms, t times 1. So that will be negative 2 times t. So that's negative t minus 2t. Amen. Plus the square of the last term, which is negative 1 all squared, that is positive 1. 7 minus t. Take everything to the left hand side, and you're left with t squared minus 2t plus t, if you take this to the left hand side, plus 1 minus 7, if you take the 7 to the left hand side, equals to 0. Therefore, okay, add like terms, t squared minus 2t plus t, that's negative t. 1 minus 7, that's negative 6, equals to 0. All right, factorize this. T and t equals to 0. Then we've got 3 and 2 that give us the last terms. Let me fix that. 3 and 2. 3 and 2. So that's minus 3 plus 2. Therefore, Sorry, that was bad. Therefore, t plus 2 equals to 0, or t minus 3 equals to 0. Therefore, t equals to 2. I mean negative 2. See, this is why I never cut corners here. And then t minus 3 equals to 3. All right, let's check. Always check. We're going to check step by step. Let's check for t equals to 3. All right, the left hand side equals to 3 minus 1, which is equals to 2. The right hand side equals to square root of 7 minus 3, which is equals to square root of 4, which is 2. Equals to right hand side. Left hand side equals to right hand side. Therefore, the t equals to 3 checks out. Therefore, t equals to 3 is a solution. All right, let's check the other one. T equals to negative 2. Okay, left hand side is equal to negative 2 minus 1, which is equals to negative 3. And then the right hand side equals to square root of 7 minus negative 2. And that is equals to square root of 7 plus 2, which is 9. And that is equals to positive 3. And that is not equals to the left hand side. The left hand side in this case is not equal to the right hand side. Therefore, t equals to negative 2 is not the solution. Therefore, our answer is t is equals to 3 is the only solution. Very important. Only solution. This is the case where checking really helps. Now, last question. This is the applications of exponents. The question says Ngobani invests 5,530 into an account which pays out a lump sum at the end of 6 years. So you've got your term, 6 years, all right. If he gets 9,622 rand 20 cents at the end of the period, what compound interest rate did the bank offer him? Give answer correct to 1 decimal place. So we're looking for the interest rate. Here is a situation where we're looking at a compound interest formula or question, where the formula is basically A equals to P in bracket 1 plus R over 100, or I, if you prefer, R over 100, okay, to the power of N, or I. Let's keep that as an I instead of R over 100. We're looking for, we know what the final amount is. We're given there, it's 9,622. And we know what the initial amount is she invested. That's 5,530. We know what the term of the investment is, that is 6 years. But we don't know what the interest rate is, and that's what we're looking for. That's what we're looking for. All right, so we're looking for I. meaning that we need to make I the subject of the formula. Let's start with that. Let's make I the subject of the formula. Therefore, okay, A over P, divide both sides by P first. A over P equals to 1 plus I all to the power of n. Now, therefore, find the nth root to get rid of the power. So the nth root of A over P is equal to 1 plus I. Now let's get I on its own. Therefore, the nth root of A over P minus 1, let's get I 1 to the left hand side. So that's minus 1 is equals to I. Now what you do is you substitute. So you go the nth, the sixth root of your A is 9,622 rand 20 cents over your P. The initial amount is 5,530. That is equals to I. Take out a calculator and you go 6. Sorry, that is all. Okay, that is all. Minus 1 equals to I. Sorry about that. Now let's calculate I. Take out a calculator and you go 6 second function y to the power of x, y, that is, and then you go 966,622.20 divided by 5530 equals to, and then minus 1. So you go 6 second function y to the power of x in bracket 9622,20 divided by 5530 close bracket, then you go minus 1. That is equals to, it will give you 0, 0.096. So that's 0.096, 0.096, 0.096, 709, blah 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 blah. That is equals to I. Now, in order to find the percentage, multiply that by 100, and that gives you 9,670 blah 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 equals to I. Round that off correct to 2 decimals and it gives you 9, or 1 decimal. So that gives you 9.7%. And that's the answer to the question. We've come to the end of this long video. Thank you for your time. If you've got any questions or you have any suggestions, comments, please leave a comment on the video and I will attend to you. See you in the next video. Bye.